So dear students, we have completed fabric strength, seam strength and yarn slippage. Now we are into fabric thickness. Measuring fabric thickness is not a routine quality control procedure in the apparel industry. However, various properties such as warmth and bulk are dependent on fabric thickness. Very important point. So, warmth and bulk are dependent on fabric thickness. Thicker fabrics generally entrap more air within the fabric structure, creating a thicker shield between the skin and the environment, thereby providing more warmth. So, thicker fabrics will give more warmth. Measuring fabric thickness is also used for evaluating the abrasion resistance of a fabric or textile material. So, measuring fabric thickness is also useful for evaluating the abrasion resistance. Also, sometimes the garment manufacturers rely on a fabric thickness measurement in calculating the number of fabric layers in cutting garments and determining settings to use for stitching on sewing machines. Also, sometimes the garment manufacturers rely on a fabric thickness measurement in calculating the number of fabric layers in cutting garments and determining settings to use for stitching on sewing machines. So, garment manufacturers rely on a fabric thickness measurement so that the number of layers in cutting garments on a sewing machine are determined by fabric thickness. Fabric thickness is measured by a thickness gauge such as the one shown in figure. So I have to show you the figure. This is the figure. The thickness value of most textile materials will vary considerably depending on the pressure applied to the specimen at the time of thickness measurement. So, thickness value depends on the pressure applied to the specimen at the time of testing. In all cases, the apparent thickness varies considerably with the pressure applied. For this reason, it is essential that the pressure have to be specified when discussing or listing any thickness values. So when you are giving thickness value, you have to mention the pressure at which it is measured. Also, since the textile material is resilient, the thickness reading will not be stable for the first few seconds after putting the specimen under the thickness measurement gauge. Therefore, it is essential to specify what time interval after what time interval the thickness measurement should be taken so that it would be stable. For many materials, 5 seconds after the full load has been applied will represent a stable and suitable time interval. It is customary to take at least 3 to 5 specimens to test, and the final result is expressed as an average of the test results of these specimens in terms of mm. ASTM has a standard test method for measuring fabric thickness, D1777, standard method for measuring thickness of textile materials, Annual Book of ASTM Standards, Volume 07.01. So, dear students, fabric thickness, it is very simple topic, very simple topic. First point is fabric thickness is generally is the fabric thickness, but in terms of garment it may be a measurement of the warmth and bulk of the material. That is one point. And next important point is when we are measuring fabric thickness, the pressure at which the load is applied onto the fabric while measuring the fabric thickness is important, and that should be specified while mentioning the fabric thickness. The next point is the time interval after the full load is applied on the test specimen. 5 seconds we have to wait, and then we have to take the measurement of fabric thickness. Then that is correct procedure. Next is we have to take 5 specimens and we have to measure the fabric thickness of 5 specimens and take the average, and that is the final thickness of the fabric, and that is the result. ASTM standard procedure is D1777, standard method for measuring thickness of textile materials, which is published in Annual Book of ASTM Standards, Volume 07.01. So with that I want to conclude, but you see, I get ideas. So we will go to now video, because it is not very that important, but why should we neglect anything? So I will show you the fabric thickness tester and fabric thickness testing. It is very simple and it will be shown in the video, and after that we will study about bow and skewness in woven and knitted fabric. Bow and skewness in woven and knitted fabrics, which is quite technical. Fabric thickness is not at all technical, it is very easy. So what happened? Only 51 seconds. That is not good. This is good. 4 minutes. I will have some time to break. I will get some time to break, and also it is okay. Let us go to God told me that show them the least one, easy one. I'm just joking. So this is only 392 views. So let us see 2 or 3 videos. What is wrong in that? So, and after that we will go to fabric bow and skewness bow and skewness in woven and knitted fabrics. So while this rotates, I will try to read about bow and skewness because I don't want to waste time. Okay, let's wait for some time.
घर जाने का और बहुत मन कर रहा है पर जा नहीं पा रहा हूँ। पापा के पास हमारे पैसे नहीं है।
this is generally manually tested. But not the fully automated. It's the class. Okay. But video was fully automated. So this is manual, kind of manual. So this is the thickness gauge. We are keeping the fabric and the weight is applied and thickness is measured. And it is converted into mm and centimeter. Centimeter is converted into mm. So that is the simple. This I should have shown this video, but anyway, sometimes bloopers happen, mistakes happen. So this is the thickness gauge, and now so we have what we have to learn is there is digital testing, digital fabric thickness gauge. Here in this, whatever you are seeing on the screen, here you have to calculate the fabric thickness, convert those numbers into millimeters again. And but in the digital fabric thickness gauge, we don't need to do anything, just write down the value mm. So here you see there is a small screen, small dial, and there is a big dial, and we have to convert into centimeters, and this will be little bit problematic for some people who don't know mathematics. But digital gauge is very easy for anybody because you just need to write down the value. So now we will go to, that is about fabric thickness and gauge. Now we will go to bow and skewness in woven and knitted fabrics. This is some kind of little bit technical thing. In fabric thickness, there what is there, you have to measure the thickness, that's it basically. So bow and skewness. Skewness is also known as bias in woven and knitted fabrics. So filling yarns in woven fabrics and courses in knitted fabrics usually appear as straight lines perpendicular to the selvage of the fabrics. When there is a deviation from this perpendicularity, the fabric is said to have a bias or bowed condition. The ASTM D123 defines bow and skewness as follows. Bow, B-O-W, bow. A fabric condition results when filling yarns or knitted courses are displaced from a line perpendicular to the selvage and form one or more arcs across the width of the fabric. See figure 5.10. So figure 5.10 I have seen. Skewness. A fabric condition results when filling yarns or knitted courses are angularly displaced from a line perpendicular to the edge or side of the fabric. Skewness is also called bias. See figure 5.11. So what is the difference between angularly bypassed? So I will show you the figures. I will show you online also. So you see, this is bow. The D is bowed yarn. D is bowed yarn. And here this is skewness. So anyway, so I will study one more. Let us. I will study and then we will go to online. So to show you all the things, bow or skewness can be induced from during cloth manufacturing, dyeing, tentering, finishing, or other operations where potential exists for the uneven distribution of tensions across the fabric width. Bow and skewness are more visually displeasing in colored pattern fabrics than in solid colors because the contrast makes the distortion more prominent. Also, such condition may cause sewability and drapability problems. Such a condition may be more noticeable in small parts of garments such as collars, pockets, etc., rather than in the big parts. Bow or skewness in a fabric will sometimes cause a garment to twist in laundering, such as a twisted leg on a pair of jeans or a twisted sleeve on a long sleeve knit shirt. In a survey of apparel manufacturers, bow was mentioned as one of the top 10 quality problems. Bow and skewness are illustrated in the figures, and it is also explained how to calculate the value of each. What degree of bow and skewness are acceptable depending on the type of and price line of the garment being produced, and is a matter of an agreement between the buyer of the fabric and the seller of the fabric. There are no standard values of bow and skewness that may be considered unacceptable. Method for determining bow and skewness of filling yarns in woven fabrics and courses in knitted fabrics is covered in ASTM D3882 standard test method for bow and skewness in one annual book value same always annual book ASTM standards 07.01. So now it is my duty to show you what is bow and skewness on the internet, because we have availability of internet. Bow and skewness, I understood easily. Bow I understood, but skewness is little bit. Angularly displaced means what? So this is bowing and this is skewing. So that this is the length of the fabric and that is the width of the fabric, and bows are the arcs formed along the across the width perpendicular to the width, and the arcs are formed. This is known as bow. And let us see what is skewness. Skewness is this is skewness. So the filling yarns are angularly displaced. Oh, okay, I understood. Instead of forming arcs, here they are angularly displaced. So 1 by 2 inch of in 12 feet width has happened. So that is showing with the two arrows. So that is skewness. So it is a fabric skewness is. So I am reading skewness because it is showing skewness right now on the screen. Skewness is a fabric condition results when filling yarns or knitted courses are angularly displaced from a line perpendicular to the edge or side of the fabric. So this is what it is. It is displaced, angularly displaced from a line perpendicular to the edge or side of the fabric. And bow, so this is the bow and skewness both together. So in the, I will show only bow because people want to see what is bow. Where is bow? Okay, let us show both of them. So here left side diagram is bow and right side diagram is skewness. So please understand, bow is a fabric condition, results the condition of the fabric that is resulted from when the filling yarns are displaced from a line perpendicular to the selvage. Remember that, perpendicular to the selvage, and form one or more arcs across the width of the fabric. You see the arcs are formed on the left side diagram. So this is known as bow. So this is top 10 quality defects of the problem, and bow and skewness are top 10 quality defects in a garment. So
Hi guys, welcome back to my channel.
okay, welcome. I will show you what is bow and skewness testing. Let us see that. It is not available in the textbook, but I will show you on the online. You see, I am telling you what more than that is there in the book. Bow and skewness test method. So let us on-site test at the time of inspection. Which video shall we see? That's what I am checking. 7 minutes, 4 minutes, 5 minutes. So let's see the views. 35k views. Let's go with this. On-site test series. So this is bowing check in the fabric.
Hi, this is Sanket from RSG Inspection Service. Today we will see how to check bowing in the fabric. First of all, we will see what are the instruments we required to check bowing in the fabric. First of all, we will see about the load. This load we will use while we are keeping on the fabric and we are aligning the fabric across the table edge. Then we are required metal measurement tape. This metal measurement tape should be calibrated. You can see here, this is a calibrated metal measurement tape. Then we require calculator, notebook and pen to calculate percentage of the bowing. Now we will see what are the requirements of fabric to check bowing. First requirement is this fabric should have a length of minimum 6 inches. You can see here the fabric length is 7 inches, so that this is fulfilling our first criteria of 6 inches length. Then you can see here selvage should be available at both the ends. Now we'll see how to check bowing in the fabric. First of all, we'll align the fabric on the table edge. You can see here, we align the fabric on the table edge. At the same time, we have to align the weft also on the table edge. Then we'll put load on the table. Once you put the load on the table, make sure that this fabric should not get displaced here and there. Then start spraying the fabric across the weight. Once you spread the fabric, then make sure that no any half or incomplete weft available in the fabric. You can see here all wefts available in the fabric that are across the weight and full weight. Once you're done spraying of the fabric, then you have to check for maximum deviation area in the fabric. You can see here 2.5 is the maximum deviation across the width. Now we calculate fabric width. You can see fabric width is 113.5 centimeters. Now we'll say calculation to check the bowing in the fabric. Bowing can be obtained by formula of deviation of the fabric divided by total width of the fabric
Oh,
into 100. This 100 we use because we have to define the bowing in terms of percentage. That's why we are multiplying the answer by 100. You can see here 2.5 was the deviation in the fabric and total width is 113.5 centimeters into 100. The bowing in the fabric is 2.20 percentage. Now we'll see difference between bowing and skew. Bowing is nothing but when we align the fabric on the table, this is table edge and this is table edge, then we'll align the fabric on this edge and we spread the fabric, then fabric will form bow shape. That means both of the fabric edges are aligned on the table, but somewhere it is having deviation against the table edge. So the fabric is deviating in bow shape, that's why this is called as a bowing. And apart from the bowing, another term that is called as a skew. Skew is same terminology, but the fabric will form deviation in the diagonal shape. You can see one edge of the fabric is aligned on the table, other edge is deviating from the table, and that edge is deviating in maximum distance from the table across the width. That's why you can call it as a skew. So this is how we calculate bowing in the fabric. Thank you for watching the video. Please stay tuned for more videos.
so dear students, I liked that video. We understood something, but I doubt whether it is correct or wrong. So we will see here bow and skewness. Bow percentage is equal to d by w into 100 into skewness is percentage is equal to, so here d by w into 100, skewness percentage is equal to AB or BD by BC, so AB or BD, okay, AB or BD by BC into 100. So board yarn length is equal to selvage, and so let us see one more video so that we will get confirmation. So
स्टार्ट सर। चेक्स फैब्रिक हम लोग लिया है हाउ टू मेजर बोइंग स्क्यूइंग चेक्स फैब्रिक। तो फैब्रिक ये हमारे पास इंची टेप है, परसेंटेज निकालने के लिए कैलकुलेटर है। deviation distance 1 cm. Okay, deviation distance 1 cm. So calculation Boeing percentage. So 1 cm divided 153 into 100. Why into 100? तो परसेंटेज निकालने के लिए ये चाहिए. तो इज इक्वल टू 0.6. 0.6 इज परसेंटेज. और ये दो पिक्चर है जो बोइंग कैसे आता है वो दिखाने के लिए. दिस इज बोइंग, दिस इज deviation. This is the deviation. How to make this one measure, and this is the result. This is skewing. See, that line and another line up. So this is the skewing. तो हम लोग ऐसे मेजर करता है. उसके बाद जो वर्ल्ड क्लास यूनिवर्सल स्टैंडर्ड है वो है 3%, बट लगुना फॉलोइंग 2%. लगुना फॉलोइंग 2%. तो लगुना का जो मैनुअल है, क्वालिटी मैनुअल, वो हम लोग फॉलो करता है. उससे कम होगा तो भी हम लोग पास करता है, और उससे ज़्यादा होगा तो हम लोग रिजेक्ट करके फिर अगेन मिल को भेजता है, रीप्रोसेस करके.
हाय दोस्तों, होप आप लोग अच्छे होंगे. आज हम आप लोग
We don't have time for so much. So Boeing everybody understood. So how to measure skewness? Skewness nobody tells correctly.
Hi, I am Bang Quality Engineer Vietnam World. Today I could like say to everybody about how to the manual cutting method to find out the chip, skew and bowing. Normally, some the people using cutting manual by hand like this. After that, we look the tip here to here and found out the percent how to skew. But this method incorrectly because it's not the square on the table at the table when we separate fabric on the table cutting. How to the correctly to find out the square? I using the square paper like this. The first, I set the paper parallel with the fabric end like this. You see, and I mark here, 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 here. Right. After that, I tuck here. To here, like it. No, right? After that, I cut. Right, and then we set set fabric at the end of the table. How to square with, right? You see? And then we using the sit up like cái thứ. Xong chưa? Okay, after that we using the ruler tack here at the end of the tip. Example 2 cm, right? And center 2 cm here. Right? This one, the center here, 4.6 cm, right? And then here, 5.8 cm. Here, 4.9 cm. Double check, right? That means you come back to at the end. That means on the right, my hand 2 cm, but near 0.56 cm, and here 5.8 cm. And at the end, 4.9 cm. I just say how about a skill different with normally cutting by hand. You see, okay? Thank you.
So dear students, I hope you understood what is skewness. Skewness is angular displacement. Please understand, angular displacement. So that's what I want to tell. That's the only thing. Angularly displacing from a line perpendicular to the edge or side of the fabric. Filling yarns. So that is about skewness. So thank you students. Bow and skewness are the two quality problems in the garment industry. So that ends bow and skewness.